Hello students, myself Prakash Lavande, Sri Tilok Jain, Higher Secondary Vidyalaya Patradi. Students, in the today's lecture, we will see the different ways of expressing the rate of chemical reaction. Students, there are two ways to express the rate of chemical reaction. The first way is the average rate of reaction, and the second way is the instantaneous rate of chemical reaction. So we will see one by one. So we'll start with the average rate of chemical reaction. Students, you know that whenever any chemical reaction proceed, it requires some time to complete that particular chemical reaction. Now, whenever you carry out any chemical reaction, during the reaction, the concentration of reactant as well as the concentration of product changes with the time. And therefore, as you know that rate is nothing but the change in concentration of reactant or product per unit time, that means the rate of chemical reaction, it is continuously changes with the time. See here, for this particular chemical reaction, the rate for this particular chemical reaction, the rate of reaction, it is continuously changes with the time. Why does it going to continuously change with the time? Because the concentration of reactant or product continuously changes with the time. It will be never constant. It will be, remember this one, it will be never constant during any time interval. It will be never constant during any time interval because the concentration of reactant continuously changes with the time. Now, let us suppose you have to assume this particular chemical reaction, and let us say this chemical reaction, it is going to complete in 30 minutes. So, during this 0 to 30 minutes, so while determining the average rate of reaction, what you have to do? You have to choose two different time intervals. Okay, so whenever you determine the rate with the help of two different time intervals and two different concentration terms, so that particular rate, it become average rate. Means here, while determining the average rate of reaction, you have definite time interval. And in between that two definite time interval or any rate of reaction which is determined, which is measured over definite time interval that you have selected, so that rate, it is called as average rate of reaction. Are you getting this? So first of all, your definition should be clear. So what is the definition? What is average rate? So average rate is the rate of reaction over definite time interval. Now question arises, how to determine that average rate of reaction? And for that purpose, I will explain this with the help of these two graphs. So these two graphs are nothing but first graph. So this is graph for this particular chemical reaction, A gives B. Now this is the graph for reactant and this is the graph for product. Now as you know that whenever any chemical reaction starts, concentration of reactant as well as concentration of product changes with the time. For the reactant, concentration of reactant, it is maximum, and with the time the concentration of reactant decreases. In case of product, the concentration of product initially it is 0, and when reaction start, the concentration of product increases with the time. Now with the help of these two graphs, we can determine the average rate. Now as I told you that whenever you have to find out the average rate, what you have to do? You have to select two different time intervals and two different concentration terms related to that two different time interval, and if you have this data, then you can determine the average rate of reaction. Okay, so let us say on the basis of this curve, let us say first of all you have selected this time t1. Okay, time t1, at time t1 the concentration of reactant, it is A1. Okay, and when in time t2, at that time the concentration of reactant, it is A2. Clear what we have done? You have selected two different time intervals. Okay, so in between two different definite time interval, that is average rate. So two different time interval, you have two different concentration terms. Similarly, if you have to find out the average rate with respect to product also, so in that case again you have to select two different time interval. Let us say when time t1 is there, the concentration of product is B1, and when time t2 is there, concentration of product is a B2. Clear? So from these two curves, now you are able to determine the average rate of reaction. So how to determine that average rate? For that purpose, with reference to that graphs, I can write here, at time t1 the concentration of A is A1, clear, and concentration of B is B1. Is it clear from that graph? Now at time t2, concentration of A is A2 and concentration of B, that is a B2. That means you have two different time intervals and two different concentration terms. Now with respect to reactant, how much change in the concentration? So we have used here delta. That means whenever you use delta, that means that is related to large change in between two different time interval. So delta A is equal to A2 minus A1. With respect to product, the change in concentration of B, obviously it is going to increase. In case of reactant, it decrease. So change in concentration of B is equal to B2 minus B1. Okay, so you have find out how much change in the concentration. Now you have the simple definition of rate of chemical reaction. So what is rate of chemical reaction? So change in concentration upon time taken. So with the help of this, you can write with respect to reactant, rate is equal to minus delta A upon delta T. Now why do we put minus sign here? Because concentration of reactant continuously decreases with the time. Therefore we put here minus. With respect to product, the rate of reaction is equal to plus delta B upon delta T, and this is how these two ways are nothing but they are called as the average rate. So for this particular reaction, A gives B, the average rate becomes minus delta A upon delta T is equal to delta B upon delta T. So this is how you can determine the average rate with the help of your graphs. What you have done? You have selected two concentration terms at two different time intervals. So that will give you the average rate of chemical reaction. But if you are not any simple chemical reaction, if you are any other reaction which having different stoichiometric coefficient, because in the previous reaction the stoichiometric coefficient of A is 1, here B is also 1. So this is the simple reaction, and for this simple reaction average rate expressions are also very simple. But if you have any chemical reaction in the form of this one, AA plus BB, that gives you CC plus DD, means here your reactants are capital A, capital B, your products are capital C and capital D, and small a and small b are the stoichiometric coefficients of reactants, and small c and small d are the stoichiometric coefficients of product. Means this is the reaction having different stoichiometric coefficient, and whenever you express the average rate in case of this particular reaction having involving different stoichiometric coefficient. So in that case, you write average rate is equal to. So what you write with respect to, whenever you write the rate with respect to reactant, at that time what you do? You write delta A upon delta T as usual, isn't it? Also you have put negative sign here because you are writing the rate with respect to reactant. But very important change that you have to make here is that here for such a reaction, the coefficient of that reactant, with the that coefficient, you have to divide this expression by that coefficient. That means A is a stoichiometric coefficient, so you have to divide that stoichiometric coefficient here, and therefore you have here 1 over A delta A upon delta T, isn't it? With respect to B, the rate become minus 1 upon B, because B is a stoichiometric coefficient, so minus 1 upon B delta B upon delta T. Are you getting this? With respect to C, C is a product, so well, with respect to product we put positive sign here, so delta C upon delta T, stoichiometric coefficient is C, therefore 1 upon C, and here stoichiometric coefficient is small d, so 1 upon D delta D upon delta T. So what conclusion that you can draw from this? So whenever you write the rate of reaction for average rate of reaction for the reaction having different stoichiometric coefficient, in that case that coefficients, stoichiometric coefficient, you have to use as a division. You have to divide that particular rate expression by that stoichiometric coefficient. Okay, so we can predict the rate of change of one of the reactant and product based on rate of change of other. Okay, based on rate of change of other. We cannot predict the rate based on balance equations alone. So on the basis of balance equation we cannot determine the rate. So whenever we determine the rate, at that time we have to determine, we have to predict with respect to the another one. So this is what you have to remember in this particular point, that is the average rate of reaction. In exam they may ask the question, what is average rate and how it is determined. So this is what about the average rate of chemical reaction. Okay, so I will give you a simple example how to determine that average rate of reaction for a simple reaction. Suppose if you have any simple reaction like this, N2, okay, plus thrice H2, and that gives you, suppose or not necessary to write here the arrow also. So for this reaction, twice ammonia. So this is the chemical reaction, and for this reaction suppose you have to write the average rate expression. So average rate, AR means average rate, with respect to N2. So with respect to N2 it become minus delta N2 upon delta T. Okay, with respect to H2, so average rate become, with respect to H2, the average rate become minus delta A, sorry, H2. So reactant is H2 upon delta T. Now here the stoichiometric coefficient here is 1, so we have not divided here by 1. Here the stoichiometric coefficient is 3, so I will divide this expression by 3. So this is how you have to write the average rate for the particular chemical reaction. Then third one, that is the average rate with respect to ammonia. So with respect to ammonia it become delta change in concentration of ammonia upon delta T, and here the stoichiometric coefficient is 2, so we will divide here by 2, and here this one is a positive. So this is how you can apply the concept of average rate for different chemical reactions. Are you getting this? So this is how you apply. Now these three rates, they are equal. That means you can write, minus, you can write minus delta n2 upon delta t is equal to minus 1 by 3 delta h2 upon delta t is equal to 1/2 delta nh3 upon delta t. Means these three rates, they are equal. So this is how we can express the average rate with respect to any reacting species, either reactant or either product. So this is how we can determine the average rate. Now come to the another way to express the rate of reaction, and that is the instantaneous rate. So what do you mean by instantaneous rate? Okay, instantaneous rate means it is the rate at a particular instant. Let us say your reaction is going to complete in 30 minutes. So at any time instant, let us say at time t is equal to 15 minutes. So how much is the rate? So that is called as the instantaneous rate. So simply the definition of instantaneous rate become, that is the rate of reaction at specific instant, at any specific instant. So that is called as the instantaneous rate of reaction. Here whenever you write the instantaneous rate, then instead of delta you write as a d. That is only the change that you have to make here. Delta is replaced by d, so that will give you the instantaneous rate of chemical reaction. Are you getting this? The difference between average and instantaneous. Whenever you determine the average rate, what you have to do? You have to select two different time interval, and here you have to select any specific time instant. That is any time, let us say 15 minutes or 10 minutes. So that is that rate which we call as a instantaneous rate of reaction. And this is very important change. Delta is replaced by d. So instead of delta, suppose if you put d only, you will get the expression for instantaneous rate of reaction. Now question arises, how to determine the instantaneous rate of reaction. For that purpose, again I have considered the two different graphs. One is for reactant, another one is for product. Curve for reactant like this, product like that. Okay, so whenever you write the determine instantaneous rate graphically, so what we do, we select any specific time interval. Let us say this time t, any specific point on the curve. Remember, you have to select one specific time instant, and that is a t, and then draw the tangent to this curve. So this is what is a tangent. So this is the tangent to this curve. So whenever you draw the tangent, you should remember one important thing, that tangent should not cross the curve. That is very important point. So this is the point t at which you are drawn the tangent, and then just find out the slope of that tangent. And the slope of tangent, that will give you the instantaneous rate of reaction. Okay, so you have drawn this tangent and calculated the slope of this tangent, and that comes out to be minus dA by dt is the expression for that particular instantaneous rate. With respect to product, again you have the curve like that, then you have selected any specific time instant t, draw the tangent, you will get the rate dB by dt. So this is how with the help of the simple expression, a simple concept, you can determine the instantaneous rate of chemical reaction. Okay, so this is what about the average rate, its determination, instantaneous rate and its determination. Now here very important point that you should remember here is that the average rate, okay, here the average rate you can convert into the instantaneous rate. Average rate you can convert them into the instantaneous rate. In general, you can write, suppose you have any average rate expression delta x by delta t. So if this time interval, if it is reaches to 0, approximately 0, so at that time the instantaneous rate expression will get. So we'll get the instantaneous expression from the average rate expression. That means here delta t, if tends to 0, that means it is going to convert into the instantaneous rate of reaction. So this is what about the today's lecture, that is ways of expressing the concentration of solution. In the next video we will discuss the rate law. Till then, thank you.